Let's continue talking about probability, and in particular, we're going to be doing some problems involving what's called empirical probability. Empirical means numbers that cannot be predicted, but you have to go out and take a survey in order to measure them. So this table keeps track of some people in a town who have cable TV. Some of them have basic, some have premium, some have gold membership. Some of them pay monthly, and some of them subscribe annually. Now, if we were asked to find out the probability that someone subscribes to a basic membership, for example, there's no way that you can predict that. You can't just sit there and think really hard and say, oh yeah, the answer would have to be 1 out of 7 or something like that. We won't know until we go out into the field and take survey data. But let me address another common error. Let's suppose that I did ask you what's the probability that someone subscribes to a premium membership. So there are 3 types of membership: basic, premium, and gold. If I asked you for the probability of a premium, the most common misconception is that that would be, well, let's see. There are 3 kinds. There's basic, premium, and gold. 3 kinds, 3 levels of subscription, and premium is only one of them. So maybe that probability would be 1 out of 3. That is incorrect, because there are different numbers of subscribers at each level, and it's the number of subscribers that matters. It's not the number of levels that matters, okay? So that, again, is a common misconception that I want you to avoid. So in order to correctly answer the question, we have to take a survey. Hey, people in this town, how many of you have a basic membership? 8. Well, of course, the cable company will have all those records in its files. And on your handout, these are all numbered in thousands, but on this chart, I've just abbreviated them without the thousands. Now, here's a really important key to these problems. You should make row totals and column totals. So just to be clear here, basic is the header of the first column. So that means that all these people in this column use the basic cable package. Maybe that's the one that has, like 20 channels without all the fancy sports. And then there would be another level, premium. Everybody in this column is premium, and everybody in this level is gold. And then divided by a different dimension, there are those people who pay monthly, and that would be everybody in this row. And then annual subscribers would be everybody in that row. Notice that the different kinds of package, like basic and premium, don't overlap each other. They're completely separate. Monthly and annual don't overlap each other. They're completely separate. However, the 2 dimensions do have intersections. So there are some people who subscribe monthly and to a basic membership. Right? The monthly row does intersect with the basic column. And where we see an intersection like that, we use the word and. So these are all the people who have basic cable package. These are all the people that pay monthly. And they have an overlap. They overlap at 8. The fancy word for that is their intersection. And we use the English word and for that. So in the previous video clip, we defined and as associated with multiply. We're going to come back to that point later, but in these empirical data tables, the word and really means where they overlap each other. Anyway, back to my point. It's important to make row and column totals. So let's make if we make another column that says total on top, then we're really going to be finding row totals. For example, what's the monthly total? 8 plus 6 plus 2, that adds up to 16. So there's a total of 16,000 monthly subscribers. Okay, I'm sure you could fill in the rest. What's the total number of annual subscribers? That would be across this row, 8,000. Let's also create a total row, which of course will be counting column totals. In other words, how many total basic subscribers are there? 8 plus 5 is 13. Total premiums, 8. Total gold members, 3,000. In fact, we can even find the total. 13 plus 8 plus 3 is 24,000. And that's also the same as 16 plus 8. So 24 is the grand total number of subscribers in the whole problem. So it's very important that you understand exactly what all of those numbers mean. What does this 2 mean? There are 2,000 what? 2,000 subscribers who have the premium package and pay annually. Remember, and means overlap. There are 3,000 subscribers who what? 3,000 total gold package members. And 24,000 subscribers altogether. Okay, so we need to be very clear on what all those numbers mean in order to answer the following questions. Question number 1. If you choose a subscriber, what is the probability that she chose a premium membership? So remember that whatever you're choosing among, in this case, subscribers, that goes on the bottom of the fraction. And this word is not qualified at all. It includes all the subscribers, so all 24,000 of them. What is the probability that that subscriber is a premium member? Okay, so that means that we need to count all the premium members. The total premium members, there are 8 of them. That reduces to 1 over 3. Make sure you are perfectly clear on where those numbers are coming from. Question number 2. If you choose a gold member, what is the probability that he subscribes monthly? We know that probability is always a fraction. And on the bottom of the fraction, we put the group from which we are choosing. In this case, we're not choosing from among all the subscribers. It's a conditional probability based on the condition that we are looking at gold members only. So essentially, we restrict our attention to the gold members and we ignore everybody else. Nobody else matters for right now. So we're choosing from among all the gold members. How many are there? Well, the total would be 3. And out of those 3, how many of them are monthly? 2 of them. 2,000. Okay, so 2,000 pay monthly, the other 1,000 pay annually. Total 3. Our probability is 2 out of 3. We didn't need any of the other numbers in the table anywhere. And in the third problem, I've switched around the condition from the second problem. So this time we're going to be choosing a monthly member. If you choose a monthly member, what is the probability that she has a gold membership? Is it going to be 2 over 3 again? Do you think you're going to get the same fraction if you reverse the conditions? Well, let's find out. It's going to be a fraction. What goes on the bottom of that fraction? The number of monthly members. We're choosing from among monthly members, and the monthly members are the first row. We're choosing from among all the monthly members, of which there are 16,000. And out of those 16,000, how many of them are gold? 2,000. So we ended up counting the same 2,000 people as before, but this time we're taking them out of a different pool. So we end up with a different probability. We're continuing to talk about empirical probabilities with this table. This time we're going to start looking at what are called compound probabilities. Compound probabilities involve the words and, or not. And we're going to start with not. Remember we discussed that the word not is associated with subtracting. And in particular, it usually means subtract from 1. Why do we subtract from 1? Because that's basically the largest that a probability can be. It represents 100%. So if something can either happen or not happen, then if you add those probabilities together, you get 100%. If there's a 30% chance that it will rain, there's a 70% chance that it will not. So let's try that with the problem, picking up from where we left off. We just did this problem. If you choose a monthly subscriber, what's the probability that he's a gold member? And we've solved that problem already, and we found out that the answer is 1 out of 8. So if we ask now, we're going to choose a monthly member and find the probability that he is not a gold member. Okay, so when we see not, that means that you're going to take this probability and subtract it from 1. I hope you remember your fraction arithmetic. 1 minus 1/8 is 7/8. So whenever you subtract any fraction from 1, you're basically just subtracting the numerator from the denominator. Okay, so that's really easy when we do it that way. Just to confirm or get a little understanding of why that works, basically everybody, all the monthly members who are not gold, are either basic or premium. And remember, since we're choosing monthly, we don't care about anybody else in this table. We're only looking at the first row. And out of all those 16,000 subscribers, which ones are not gold? The basics and the premiums. That adds up to 14. And what do you know? That's 7/8. Let's go on to the word and. Remember again that in the empirical table, and represents overlap. If you choose a subscriber, what is the probability that he is a basic member and is an annual subscriber? So this fraction will have the number of subscribers on the bottom. If you choose a subscriber, so how many subscribers are there? And that's represented by a grand total of 24,000 of them. How many of those are basic and annual? Well, the basics are in the first column, and the annuals are in the second row. First column, second row, that gives us these 5,000 subscribers right there. 5 out of 24. And what about the word or? Remember, we associate the word or with adding. So the next problem says, if you choose a subscriber, what is the probability that she is a basic member or a premium member? Let's form our denominator, our fraction with denominator first. We're choosing from among all the subscribers. There are 24,000 of them. How many of them are basics or premiums? So we see that there are, how many basics are there altogether? There are 13 of them. So this is the basics. And then how many are premiums? 8 out of the 24. And what does or mean? Plus. So when we add those together, we get 21 out of 24. So the basic rule here is that to find the probability of basics or premiums, we can add the probability of basic plus the probability of premium. Now I need to draw your attention, something really important about this last example, and that is the basics and the premiums are two completely different columns. They don't overlap each other. They're completely separate and distinct. Again, there's a fancy word for that. It is mutually exclusive, or sometimes called disjoint. But in any event, it's very clear that we can just add these numbers to those numbers because there's no complications involving people who might be both basic and premium. So that's the situation where we can just use this direct, very simple rule with adding probabilities.